1+1 HSB protection is reliability of microwave links. So, what is 1+1 HSB protection? 1+1 HSB is a 1+1 protection mode. In 1+1 HSB mode, IF boards and ODUs at both ends of a microwave link form a 1+1 hot standby configuration for protection. A microwave system in 1+1 HSB configuration consists of the following parts: main channel, standby channel, and a service channel unit that transmits services to or receives services from the main or standby channel. In normal cases, at the transmit end, the standby channel is muted and services received by the service access unit are sent to the receive end through the main channel. At the receive end, both the main and standby channels receive services, but the service access unit receives services only from the main channel. If the main channel at one end, such as the main channel on the right, fails, the main channel is muted and the standby channel is unmuted. The services are then sent through the standby channel, and the service access unit receives services from the standby channel. When two RTN 300s are configured in a 1+1 HSB system for one end, they serve as main and standby channels, and other cooperating devices serve as service access units. To negotiate the main standby status of microwave channels, two RTN 300s must communicate through cascade ports. Let's move on to system configuration. Depending on the type of device used as the service access unit, a 1+1 HSB system containing RTN 300s may or may not have optical splitters. First, let's look at those scenarios in which devices have optical splitters that serve as service access units. In the example, one optical splitter, two RTN 300s, and one single polarized antenna with a hybrid coupler form a 1+1 HSB system. The optical splitter can send two channels of signals but receive only one channel at a time. To ensure that services are normally transmitted and received, the access port on the current standby RTN 300 is always disabled. When the main RTN 300 is the active one, its access port is enabled, but the access port on the standby RTN 300 is disabled. When the standby RTN 300 changes to the active one, its access port is enabled, but the access port on the main RTN 300 is disabled. For details about the protection switching principles and various fault scenarios, see the multimedia presentation titled 1+1 HSBC Principles with Optical Splitters. In the example, protection is provided for one channel of GE optical services received. Protection can be provided for multiple channels of GE optical services by increasing the number of access links. To provide protection for multiple channels of GE optical services, an optical splitter must be configured for each channel of services. Note, due to port restrictions, the RTN 310 does not support protection for multiple channels of GE optical services received. Now, let's look at a scenario in which devices do not have optical splitters. If the devices do not have splitters, IDUs or customer devices supporting LACP serve as service access units. In the example, one IDU serving as the service access unit, two RTN 300s, and one single polarized antenna with a hybrid coupler form a 1+1 HSB system. The IDUs form lags with the main and standby RTN 300s, so that the IDUs always transmit services to or receive services from the current RTN 300. When the main RTN 300 is the active one, the system priority of the lag configured on it changes to the highest. Therefore, the lag setup between the IDU and the main RTN 300 works. When the standby RTN 300 changes to the active one, the system priority of the lag configured on it changes to the highest. Therefore, the lag setup between the IDU and the standby RTN 300 works. For details about lag, see the multimedia presentation titled Lag. For details about the protection switching principles in various fault scenarios, see the multimedia presentation titled 1+1 HSBC Principles with IDUs. In the example, protection is provided for one channel of GE optical electrical services received. Protection can be provided for multiple channels of GE optical electrical services by increasing the number of access links. To provide protection for multiple channels of GE optical electrical services, a lag must be set up for each channel of services. Lag status switching must be performed simultaneously depending on the main standby status of RTN 300s.